Science Comics, Coral Reefs, Cities of the Ocean, Chapter 5, Lower Reefs, Big Planet Challenges, Changes, and Taking Charge. We've studied coral as an animal, learned how reefs are formed, and we've seen the incredible biodiversity that they sustain. But life on Earth is not always easy. Who knows? Say it ain't so. Don't worry, we're learning about these challenges so we can better protect you. Phew. First up, climate change, also referred to as global warming. Climate change is something that affects the whole planet. In order to understand how climate change is a challenge for a coral reef, you have to understand what climate is. Climate refers to a long-term pattern of weather in a particular area or region. For instance, I live in a tropical climate. I never need a jacket, scarf, or mittens. My climate stays pretty constant because of the area that I live. But climate can be different in different regions. Say that you live in a temperate climate. This usually means that your climate has 4 seasons. It also means that you have to dress differently for each season. Sometimes the terms climate and weather are confused. Weather is what happens day to day, while climate describes year-to-year patterns. One hot day in the winter or one cold day in the summer doesn't mean the climate is changing. But seeing an increase in warming or an increase in cooling over 30 or more years does. And we've seen a steady increase in temperature over the past 20 to 200 years. This leads us to climate change. Climate change refers to changes in long-term averages or of daily weather. Research and data had to be collected over a long period of time to reveal information about the world's climates. This is often a challenge because humans have only begun collecting this data recently compared to the age of Earth. What we do know is that human activities have been putting record amounts of carbon dioxide into the atmosphere. There are natural sources of carbon dioxide, like when land animals exhale or from volcanic eruptions. But the major sources of CO2 in the past 150 years have been from human inventions. Our planet already has ways of managing CO2 levels thanks to phytoplankton, algae, and trees, but too much CO2 upsets the balance, burning fossil fuels like coal and gas releases carbon dioxide into the atmosphere. As carbon dioxide builds up, it creates a gassy blanket around Earth. The thick blanket around Earth traps heat. And all that trapped heat warms up the ocean. This causes the global temperature to rise, having a negative impact on ecosystems that are accustomed to very slow environmental changes. Melting polar ice, droughts, and sea levels rise are just a few of the changes from climate change. Well, this can't be good. Yeah, definitely not good. We've been looking at how climate change affects the whole planet. Let's shift our focus to how it affects coral reefs. Coral bleaching. Remember that symbiotic relationship the corals have with the tiny algae zooxanthellae? Some coral reef have taken more than 30 million years to form. Because of these pre-existing conditions, a temperature change as little as 1 degree can upset the balance that had been long established by the reef. This is called coral bleaching because corals lose their color when their zooxanthellae leave. If the temperature resumes to previous levels within a short amount of time, the zooxanthellae might return. If not, the corals can live for a while, but they will not be healthy. They may eventually die. Changes in light and access to nutrients can also cause coral bleaching, but temperature is the most likely candidate. Ocean acidification. This is a danger for not just corals, but for any animal in the ocean that has a shell. When CO2 levels increase, the ocean compensates by absorbing more CO2 to maintain balance. Too much CO2 in it can actually alter the chemistry of the ocean. We've got to get molecular to see this happen. Ocean water is mostly water molecules, about 97%, with salts and minerals making up the rest. Other elements found in ocean water, like calcium, help animals to form the shells. When more CO2 is absorbed into the ocean, it bonds with water molecules and carbonate ions to form bicarbonate, which leaves carbonate for calcium to bond with. Less calcium carbonate in the ocean is bad news for animals that need it to form their shells. Without calcium carbonate, the shells become thin and weak. A weakened shell means less protection from predators, less support if the shell is part of a larger structure, more susceptibility to damage. You don't have to be a chemist to see that this is bad news for any shell-making animal for the ocean. So we know that too much carbon dioxide is bad for our planet, but what can we do? Take action. Like any problems, we find solutions. Part of the solution is reducing the amount of carbon dioxide that was put in the atmosphere. Vehicles that run on gas release CO2 into the atmosphere. Walking, biking, or carpooling can help reduce the amount of carbon. Even better, organize a carpool group to school or sports practice. Woohoo! Plastics are made from oil. More oil means more CO2 in the atmosphere. Use a reusable water bottle, lunchbox, or snack bag to reduce the amount of plastic in your life. Get outside. Having fun outdoors helps us appreciate our awesome planet. Plant a tree, participate in a church or beach cleanup, or organize your own event for your friends and family.